I appreciate the opportunity to be able to present at this 50th anniversary event. WCER is a very special place in education, and it's also has a unique place on campus as well. And I'm fortunate to be able to have time that I could spend over here. Um, I'm going to start out by posing a question, and the question is: imagine if you could name everyone in your field that looked similar to you. And there are fields and disciplines where that can easily be done because the numbers are so small. And being exposed to individuals working in those spaces sort of led to some joint and collaborative interests that fuels my talk today and a major part of the work that we do in the WE Lab. Um, and it also situates pretty well in some of the larger challenges that the nation is actually facing. So here you'll see a data that comes from the Higher Education Research Institute at UCLA that provides a picture of the shifts in who's actually going to college as U.S. residents and are actually there and present. And you'll see that there's been a shift over time where groups or underrepresented groups historically are going to college at a much higher rate than historically has been the case. But if you take those data and you look more closely at the topic at hand, you'll see that there are opportunity areas to um, to begin to think about how we might respond to supplying the scientific workforce, which is increasingly becoming more difficult regardless of how you think about doing it, whether we continue to meet those demands as we have historically done, or whether we have to think creatively about doing it differently. And what you see here as it relates to intended interest and going into the science workforce related fields is that there are important opportunities as it relates to by gender for women and then for people of color to help fill the gaps as it relates to the growing workforce, the growing need of the workforce, but the not equitable growth as it relates to individuals to move into those spaces. So here I want to talk a little bit about some of the known challenges. We have data from the Bureau of Labor Statistics that really provide a nice picture in showing that one of the major growth areas in our economy is science, technology, engineering, mathematics-based fields. Um, but we also know from similar data that people of color interested in going into these spaces are not keeping pace with these opportunity areas. And as you begin to think about how the nation appears to be looking to respond to these particular challenges with the broadening participation movement that you see in the National Science Foundation and other governmental agencies, that there's a clear understanding that the opportunity space as it relates to getting groups that historically have not been a part of the science workforce to become interested and be critical aspects of these new emerging areas. And so one of those components that we've spent a lot of time looking at is the growth in people of color in these particular spaces. Now we have a confounding dynamic in that you have interest areas that need to be cultivated, but at the same time, degree requirements that are playing a significant role in who can be available for those positions. And then in addition to the new occupational areas that are evidently coming before us between now and 2022, There's also going to be this projected a 14.3% growth in the number of jobs that will be available during that same time, ultimately projecting that we'll need to come up with approximately 1 million individuals that we may or may not have available to fit these roles. And why this becomes critical as we think about how we will respond to this is that if you look at the historical data on how we fulfill these functions in our nation's economic space, we've relied heavily on individuals born in other countries coming over, obtaining their education and staying, and we've also relied heavily on white males to populate these positions. And if you look at the data on who's going to college, you'll notice that there's a decline overall in men. And what gets lost in that discussion of decline is that there's a decline in all racial and ethnic groups, but it's more intensified when you bring race and ethnicity there as an intersection. So some of the ways that we have been able to participate in dealing with the discussions around how you might diversify the scientific workforce is that we've been fortunate enough to have several National Science Foundation grants that were intervention-based projects that we work with collaboratively with scientists that have both been demonstration level projects, which are smaller projects, and alliance level projects, which are multi-institution, multi-year, and multi-million in nature, and I'll say a little bit about those as well. At the same time, we've also had the opportunity to participate with a couple of task force who've had particular interest in what is going on in a particular state or in a region, and I'll talk a little bit about that as I outline some of our past projects. These projects also have generally focused in several areas to kind of respond to these larger questions. One has been really trying to understand the barriers and opportunities that are in place as it relates to both women and people of color, and why might there not be similar interest in going into the science-based fields as we might see in some of the other possible fields available. We've also spent time looking at the pathways to STEM education. So how might one's interest get piqued as it relates to going into these particular fields? And as you can imagine, as most of you carry a computer around on you almost at every moment, that it's a different space as we think about how you can capture that interest, because many of these smartphones we have, they're miniature computers. And so if you spend a lot of time on those and find value in it, or if someone can help cultivate the interest, you can begin to see the connectivity to everyday life and living. We've also conducted studies to spend time really talking with participants to understand what are the motivating attitudes that are in place as it relates to STEM occupation and careers. So what attitudes are in place that prevent individuals from wanting to become scientists, and what attitudes are in place to cultivate that interest? And we found some pretty interesting and we've found some pretty interesting things that you might find laughable, but these are real experiences for people. And then we've also, through the task force, been able to spend time considering the community and family-based perspectives on this. So if you can imagine a first-generation student or someone that has an interest in a space and no one around them is remotely aware of what that is or what kind of occupational careers can be available, that you got compounding challenges there once again, in that looking for a support system to be comfortable with the majors that you're choosing and a decision that you're making becomes quite the challenge when you are focused on groups that are less likely to come from spaces where these are predominant work options. So just a little bit about the projects that we've had funded that are completed. I'll start with number 2 because I'll end with number 1. Our first project was called the African American Research in Computer Science, and this was a demonstration project funded by the National Science Foundation that had multiple components to it, and ultimately what motivated the computer scientists to want to pull a project like this together was that they could point to other science spaces like engineering having affinity spaces and groups that they could come together and work together, but computer science was not quite that way. And so this demonstration project was funded to bring together on an annual basis what appeared to be almost everyone in the field, but it also had a mentoring component both for undergraduates and future faculties, which I'll say more about in a moment. We also was fortunate enough to be a part of a project out of Arizona. So Arizona has a project that they fund that looks at a host of challenges for the state called Black Arizona. And the topic changes. So about 4 years ago, the topic was STEM, and we were invited and commissioned to look at the attitudes in the community and among family members to help understand why those factors could play a role in those that go into STEM and those that don't. And as you can imagine, there's a great deal of connectivity between feeling that you have support and having a level of comfort in going into a new space. The other project that we were actually able to participate in is something called M7. So M7 stands for Milwaukee 7. So some of you may be familiar with this. So Milwaukee 7 is the 7 counties around Milwaukee. They have a task force, and one of the questions that they were wrestling with was whether that the M7 space was fertile for a STEM corridor. So they wanted a survey to be done of STEM professionals in the area, and we were a part of that project and found that while there's a great deal of interest in being a STEM corridor, there's a major brain drain challenge that space deals with that was a major impediment in moving that idea forward. Then popularizing computing into Maine is PC2 Maine. It's what we call PC2 Maine, and that particular project was an intervention that was for elementary age kids, where they would engage with computer science as a field at the Nationals and the Wizards game. They had a demonstration table set up where it was video games, computer apps, and all the cool things that you do on a daily basis. And then the back end story was to highlight how it was computer science and then invite them to the summer-long program where they would be exposed to how to actually build those particular things. And then lastly, the software design and development team and tournament was an attempt to create computer software and design and develop an analog between sports. And so these were teams across about 7 institutions in the Research Triangle area that competed as if it was a tournament in sports, and so it made it quite an interesting twist on computing science. Just to say a little more about one of the projects, A-Force project, which was the first one that was a 4-year, I'm sorry, 5-year alliance level grant that was focused on increasing the number of African Americans getting PhDs and going into computer and science spaces. But it was a pipeline. It was a pipeline-based program that started with undergraduates. So if you can think about developing your objectives, you're dealing with undergraduates, but you're supposed to have PhDs done at the end. Somewhere in the beginning of that the architects didn't quite add those numbers up. So, but the program did do some pretty interesting things around attitudes and career exposures. And so one of the major driving components of it was this whole notion of research pods. So the research pods paired students, undergraduate students that were at historically black colleges and universities with a faculty member at the HBCU, and it also had researchers at an Research One institution all paired together. So they worked as a team, and so within these teams, some of the things that emerged was that the way the research courses were structured, which was both online and in person and across the year, so it was more like a larger module, that the relationships through that course and the feedback loop helped the students establish meaningful relationships with the faculty and the graduate students and peers that were in the research pods. It made it more of a welcoming space to learn about research. The next component that I'd like to talk about is also nested in this pod space, is that because of the unique opportunities to engage both across the academic year and in the summer through the NSF research, undergraduate research experience, structured experience, the participants talked about the value of the faculty advisor and research mentor and helping to dispel myths about what it means to be a professor, what it means to be a scientist, and what does it mean to have your primary function being research. And that meant a great deal because one of the critical barriers that you will often read about as it relates to diversifying the science workforce is that there are myths out there, and those myths about what a scientist looks like, what they do, they don't neatly lay over being a female or being a person of color. And so it's very difficult to see oneself in the field without these types of close relationships. And in closing, on this slide here, they were able to create this community that was really focused and embraced around this culture of research. And in this particular space, what they found that the general perception was that students benefited greatly from their participation because they were exposed to role models, which is a key aspect of being exposed to role models, career and career aspirations. But they were also able to learn more about graduate school and participate in graduate school-like activities and sit in courses during the summer. As well as the program itself had an internal recruitment component to it. So if you can imagine being an undergraduate and you're working with a professor for 4 years and you do very well, there's a high likelihood that you may be recruited to their lab to come to graduate school, and there was a lot of that occurred. And then the professional relationships were quite helpful as it relates to whether they did go to graduate school or they went out into industry. And then lastly here, the last component was a future faculty mentoring program. So this was a program that worked with computer science students in their last year, and it was primarily for job search support. And through that process, boot camp components, it was weekly teleconferences and a vetting of opportunities and roles and advocacies that's going on. And what you would see from the results here is that on any given year, approximately half of the African Americans that were hired in computer science came through the program, because the program did a good bit of advocating. But then ultimately, in year 4 and 5, departments became aware of the program and started seeking out potential candidates from the program. So at this point, I will say thank you, because I know I'm at my time, and will be happy to turn the microphone over.